Hi, it's Terry Dennery of the MathWorks. So this is another one of those unanticipated videos, all right? And so the original name of this video was supposed to be, what I call it, include more mechanics. So that'll be the next one after this one. And it's really, we kind of saw the reason for this in the last video. Actually, I think I'll go in, be more specific. Where we put in an AC drive and we hit run and wait for it, but that's precisely the point, that it took a lot longer for it to run. All right, and move this out of the way just so we can kind of see it compile, and okay, it started calculating. And since it does those electrodynamic calculations, things need to slow down quite a bit because well, it's just a tough calculation, especially when you combine it with mechanics, right? And and the fact that the next thing I want to do is put more mechanics in, well, I really didn't want to have to wait through all this every time I do something a little bit different in my mechanical model, all right? And so, anyways, it's a good topic, and I want to kind of show you how we're going to work around it, all right? And in a way, the reason we can work around this as well as we can is because electric motors work so well, all right? And then if you choose the appropriate electric motor, they're very good at delivering the torque that you've asked for, right? And so that's pretty much the nature of the approximation, is we're going to just deliver the commanded torque. All right, and I want to maintain my interface so that when I'm ready, I can put that motor back in. And so use terminators to terminate the angle and angular velocity signal. Let me get my Simulink browser back up there. And under sources, I'm going to get the ground block. And so essentially, this is just saying these signals will not be used in this calculation. All right, and so that's my new interface. Let's comment out the motor components, but let's not delete them either. And again, we'll run it from the scope. And you can see it calculates super fast. Now we lose the information on voltage and current, but again, as I kind of work through my mechanics, that's what I'm going to want. Okay, so what I want to do though is really kind of make all that process a lot easier. So I just kind of have interchangeable components. And if I want to run real fast, I'm going to use this version. If I really need to understand the impact on electricity, the voltages and the currents, then I'll switch to the other one, right? And the tool we're going to use to do this, let's see if I can do this. I need to operate on the right mouse click. All right, so right mouse click, subsystem reference. And so it all fits in the screen. That's why I moved it to the left here. But anyways, it's a referenced subsystem that we're going to convert that into. All right, and we're going to call it deliver, I'll just call it DEL TCMD, torque command. Nice short name. I think I'll even put that on my copy buffer. And let's see if I can manage this. Can I move that? Yeah, this will be cool. So it's basically going and doing its process of converting something, including, if you kind of look closely, you'll just see a new file showed up in my directory I'm in, del tcmd. It's a little bit different looking in its nature, and the block itself is as well. But this is essentially is a reference now to what's contained in this file, right? And so what I'm going to do now is let's go ahead and open up that file, right? And let's create the AC motor version of this. Okay, trying to get to the save as. So it's still kind of opening up the file. There it is. Okay, save it. Okay, save as. And so we're going to use this as the basis of creating our PMSM drive. Okay. And now we'll just go back in this version, right? And so let's delete that. All right, and let's delete these guys. And let's reattach. And let's command that torque, and then now let's, oh, got confused, good, all right. And now let's send that into our output motor state bus. And now let's uncomment these two. And there. All right, and so we'll save that too. And we can close that and come back here. All right, and so from our subsystem reference, I'm going to right mouse click. And so this is a little bit unfortunate, but again, on the right mouse click, kind of out of our screen, is block parameters. All right, and so that opens up this user interface, and it's here that we will make our choice. What we call it again? We call it PMS. There it is, PMSM drive. Okay, and it's telling you very clearly which version it's using, and then I can double click on the block. It's just like a subsystem, and I can come here and run it from the scope. So here it comes. We'll see the longer calculation to handle, I'll call it the richer electrical model that's presented with the PMSM drive. Okay, and now just to kind of prepare for our next demo is let's switch it back into the really fast version and block parameters. And you'll recall I copied the name before, so I think I can, yep, DEL capital T CMD. All right, and I'll just run it from here and we'll hit run. And we'll see it calculates super fast. All right, and so that'll be perfect as we move into our mechanical modeling uh, video. And at the end of that one, I think I will switch it back to the AC motor just so you can kind of see how cool it is, kind of this electromechanical interaction. That the mechanics affects the electrical affects the mechanics. Anyways, it's cool to be able to put them all together too. All right, very good. Thank you.